Hi there, and welcome to this third episode in the yt-napari tutorial series. Today we'll be talking about the Jupyter Notebook interface for yt-napari that lets you load in data into Napari Viewer from YT via Jupyter. We'll talk through some of the helper modules. Today we'll just be talking about the yt-napari.viewer module. And then we'll talk about how to load in samples of regions. So we'll add a sample of a single field. We'll adjust some Napari keyword arguments. We'll work through adding multiple fields for a region, as well as adding multiple regions. And then finally, we'll talk about linking layers that we've added within Napari. And the last bit, we'll cover briefly how to load in slices, which follows pretty much the same syntax as loading in regions. But yeah, so let's get going. So today we'll be using a Python virtual environment that we created in a previous tutorial video. So go check out the previous episodes if you want a hand getting that set up. And thanks again to the Chan Zuckerberg Initiative for the funding that made these videos possible. Okay, before we dive in, I just want to point out real quick that in the yt-napari .readthedocs.io page, you can scroll down and check out the example notebooks. So today we're going to be covering basically these first three notebooks. We'll be following pretty closely, but there might be some differences as I'll be working through them live. But if you want a resource for later, go check out these notebooks on the documentation page. So first off, let's activate our environment. So we are working with our yt-napari tutorials environment that we built in the previous tutorial episodes. So go back and check that out if you need a hand setting it up. One modification that we'll do, however, is upgrade yt-napari. So pip install -- upgrade yt-napari. Because since I recorded this first couple of videos, we've actually released a newer version of yt-napari that includes some new features, most of which we won't actually touch on here, but you should upgrade regardless, because some of the syntax of some of the functions we'll use today has changed a little bit. But in any case, let's get started. So let's open up a new Jupyter Lab instance. And open up a notebook. So let's import some stuff. So we got YT, we got Napari, and then from yt-napari.viewer, we will import scene. So let's do a couple of things before we dive into what this scene object is. First, let's load in some YT sample data, and we'll be using isolated galaxy for this. And then let's spawn a new Napari viewer instance. Viewer. And we have our Napari GUI now linked to our notebook. And so this scene object, go ahead and instantiate a new instance. And what the scene object does is help translate YT selections to the Napari coordinate system. So Napari, when you add in images, you have lots of optional arguments so that you can specify how different layers are positioned relative to other layers. So there are some arguments like scale and translate to the viewer.add_image function. And so what this yt-napari scene does is it just calculates those scales and translations from our YT samples, so that you don't have to go and calculate those and offset them correctly. So it saves you a little bit of thinking about how to orient your different samples. And yeah, so first off, let's take a look at what is in our scene object. So We got add region, add slice, add to viewer is an old function that we won't be using, and then we'll touch on these other ones later in the video. So right now we're going to walk through how to use this add region. So this add region function has some arguments here. So we have our Napari viewer that we want to add to, we have our yt dataset that we want to sample from, and then we have a field that we want to sample. And then the rest of these define how to sample and then handle the field that is sampled. So we have our resolution for our fixed resolution sample, the edges of our box that we want to sample between. Take log is whether or not you want to take the log of the field. If you don't set this, it'll pull whatever defaults you have for the fields that you're loading. And then we'll talk about the other arguments a bit later. So first off, let's define our edges and resolution that we want to use. So cool. So let's do this. Left edge equals. What we'll do is just create some left and right edge arrays that are offset from the domain center. So we'll subtract off 40 kpc in the negative, or in the negative direction from the center, and then our right edge we'll just do the opposite, so that we end up with a uniformly sided box. And then let's create a resolution tuple. Let's do 400 in each direction, and then we can go ahead and call add region. So we give it our viewer first, dataset, field, let's do density here, give it our resolution, left edge, and right edge, and let's go ahead and call that. And go over to the Napari viewer, and you'll see that you should have a enzo_density layer now, and it's loaded up in 2D right now. So the slider here takes you through the axis not being plotted. Flip the dimensions here so that now we're normal to Z, and we see our nice galaxy in the middle here, or switch over to 3D and have our 3D rendering. Cool. So that's how you add a single field. And after after you load in this layer, you can modify it by modifying all the layer control attributes here. If you want to, when you initially load in this data, you can actually supply keyword arguments. So for add region, so it does name color map here just because that's a commonly used one. So let's say color map, let's use the magma color map. And then so any extra keyword arguments actually get passed to the Napari viewer add image function. So all of these keyword arguments can be supplied to this add region, and it'll just get passed along. So for example, we could say let's give our layer a name. So let's just call it density. Now we have our density layer loaded up with the name we gave it and the color map we specified. So that's cool. And so to add in other fields, you just call this add region function again with the same arguments to sample the same region. So we'll do a temperature. We'll also change our name and our color map. Let's just get rid of that. And now we have our temperature layer, and for now let's switch back to 2D here. So we have our temperature field, density field, and let's actually adjust our color maps a bit so that we can easily see both of the fields. So the temperature layer here is on top, so let's change that blending parameter, so the opacity here, you can drop that some to see the underlying density field, and let's change that to a channel that's not present in the other color map, so that and actually if we change our blending to additive, we're adding the red and green channels or color maps together, so you can still see both fields decently well. Let's switch that back to 3D, see what we got. Cool. So we have our temperature field and our isolated galaxy density disk, or galaxy disk. Cool. Okay, so that's how you add separate fields. You just repeat the call with separate field names that you want to load in. You can also add separate regions. So let's actually do that. And just to make sure, let's get rid of those and we will resample them. So the first one, let's add in our density at the same with the same bounds as before, and then let's create some new edges here. So let's offset our temperature edge by 20 kiloparsecs for the left edge, and the right edge, let's just change how far we offset. Oh, but we should actually use those values. Okay. Right edge, left edge, temperature, and call that. So now you can see our temperature field is a subset of the whole domain here. And let's switch back to 2D for now. And actually, let's switch this back to, let's say we had density as green before, temperature is red, and switch that blending to additive, and adjust contrast limits there. Cool. And see, again, see our temperature zones relative to where our density is high. Cool. That's fun. Let's see, what else can we do? Let's get rid of these layers. Great. So that's adding two different fields, two different domain bounds for the sampling. You can also sample the same field in different domains. So this might be useful if you want to highlight different features and just kind of look at so this is how you add samples of different fields with different bounds. You can also sample the same field over different bounds, which can be useful if you want to highlight certain regions or just kind of look at how things are varying in certain regions without looking at the whole domain. So as a quick example, let's create first so we're going to do different bounds, same field here. So in this case, let's do a smaller box for our initial sample here. And then for our second left edge, we will first offset by 10 kiloparsecs for the left edge. And then our right edge we will actually calculate as an offset from our left edge. Let's go another 20 kiloparsecs. So we'll end up with a box that's still 20 kiloparsecs wide, but just different centers. So we're going to add in our density again. We're going to give this layer a different name, and we want to actually use the new edges that we're calculating here. So when you do that, go back to the Napari image viewer, you now see that we have our two regions separated or sampled separately, so they appear as two separate density layers within our Napari viewer. And then might as well go and add in our third one here. So left edge 3. We're gonna actually move this one not uniformly, so we'll use an array here. Offset it by -10 kiloparsecs in the first two dimensions, and then +10 in the final. Right edge will still be relative to our new left edge, and again, let's make it 20 kiloparsecs wide, and then add in our region once again, using our new bounds. And now you see we get our layer that shares a face with one of the other quadrants that we added. So as I said before, like since we're loaded in as separate layers here, the color limits here are being calculated for each layer individually. So there's a number of ways we can fix that. So the first is the scene normalize color limits function. So this takes in a list of layers you want to normalize across. So this can either be, you can either provide by the layer name, the string name. If you do that, you also have to provide the viewer layer list. So the Napari viewer here, our Napari viewer has a layers attribute. So these are the actual layers that are loaded in. So if you want to normalize color limits by string, let's just do 2 of them here. You have to provide that layers list. And now you see our middle and this outer quadrant here are now normalized. You can instead just provide the base list of layers, which is good if you want to normalize across all layers, and since we have the same field here, it'll do that pretty simply. So yeah, so now we're actually normalized properly across our different samples here. In Napari, you can also link layers so that they have the same, so that they react the same to changes in contrast limits and color maps. So if you already have the layers loaded in, you can select all of the layers that you want to link, right-click, hit link layers, And now when you change the values for 1, it changes across all of the different layers here. If you know ahead of time that you're going to want to link layers, you can actually provide arguments here. So let's delete all those. Let's go back and add our first layer again. And oops, went too far up. So if you provide this link to argument, when you load it in, the image will be automatically linked to the first one. So that when you make changes here, they will instantly get applied. When you initially load it in, they do end up scaling separately, but you no longer have to have that extra step of linking them before adjusting the properties across layers. Cool. So that is, at this point, we've walked through adding single regions for separate fields, multiple regions for the same fields. Let me double check to make sure that I hit all the points here. Right, so now let's start a new notebook for this. Okay, so here's our new notebook, and we're going to walk through how to add slices to Napari from yt object. So let's load in our isolated galaxy again, and get our Napari viewer, as well as our scene object here. Cool, so let's go ahead and add a slice. So scene.addSlice, very similar syntax to add region, except it's following more or less the yt sliceplot API now, where we, in addition to our viewer, we have our dataset, our normal axis field, and then center of our slice, resolution of the slice, width and height, and physical distances of our slice. And just like add region, you can provide it color map or other keyword arguments that get passed along to the Napari add image function. So cool. So let's add some slices. So we give it our viewer, our data set, normal axis, and then Enzo density field, and we'll use the domain center, so don't need to provide an argument there. Let's give it a resolution of, let's say, 600 by 600, and let's do a 20 kiloparsec width and height. Cool, we do that, add slice, and we have our nice slice over here. You might be wondering why you would bother using Napari to make slice plots here rather than using the standard yt API. And generally, I'd agree with you. If you're working in a notebook, you're probably going to be mostly using the yt slicing API. But one nice thing you can do with Napari is create composites of different fields so that you can see how different fields co-vary. And so let's go ahead and do that. So we're gonna add a slice again, a density slice. Make this a little easier to read. But we're gonna adjust our color maps and contrast limits, just so that we have a nice consistent image here. So there's our density field initially, and then we're going to also add in a slice of our temperature field. So all the positioning is going to be the same, and let's just choose a different color map. And we'll change our contrast limits, as well as we can actually change our blending. So this is another keyword argument that gets passed along to the Napari viewer add image function. And so now we have a nice composite image where you can see the high density regions as well as the high temperature regions, which is kind of neat. And so to make a similar plot in yt would take a bit more work. You'd probably have to make the slices separately and then combine the images manually, but it is possible. But if you want a quick way to do that, the yt-napari interface can simplify that quite a bit. And then the other thing that's kind of fun to do is embed regions of different resolutions. So let's first create another whole domain sample. Just going to copy and paste the above slice that we had. Let's make a low resolution whole domain sample. So we have our field and our resolution. That's all we're going to provide, and so we get our whole domain here. And you can't really resolve anything in the central region here. If subsequently we add a higher resolution sample, you can zoom all the way in, and we now have our nice little high-res sample embedded in. But as before in the region example, these are two different slices and two different layers in Napari, and so we'll want to link these two layers and just to adjust the limits here to so that the color maps are normalized between the two. And so you can actually see kind of a fun little effect of the pixelization process. So at the coarse resolution, like a single pixel here is going to take a value from everything that's included at the high resolution here. So the mismatch in colors at the edges here are simply that mismatch in the resolution sampling that you are sampling at. Cool. So that's how you work with slices in yt-napari. So to just quickly summarize what we've done today, so reminder of in the documentation, you can go to the example notebooks, check out the notebooks here. So we've talked about loading in regions, sampling different fields, as well as regions that sample different spatial extents of the domain. We talked about linking different layers within Napari and yt-napari, so that when you add regions that cover the same field but different extents, you can normalize the color limits across the domain. And then we also talked about adding slices to the Napari viewer from yt. So yeah, thanks for your attention. The next video is we're going to talk about loading regions and slices from using JSON files. Thanks for joining. See you next time.